Okay, this video is on U-Substitution integration. So it says integrate the functions below using U-Substitution and show clear and logical work on the space provided. So number one is integration of x to the second power times square root of 3x to the third power plus 5 dx. So as you can see here, there is a composite function because we have the function 3x to the third power plus 5 inside the function y equals square root of x. So obviously, if we were to take the derivative of this, then we would be thinking like x squared times 3x third plus 5 to the power of 1/2, right? And then we can like use product rule if we were to take the derivative of this. But then, and then we can also use like chain rule because we also have a composite function inside right here. But then we can't really do that in our integration methods, which is why we have to resort to U-substitution. So since we have a composite function, you can set the inside function as u equals 3x to the third power plus 5, and then du then equals to 9x to the second power dx, right? And then we can see that we can actually plug this in to x squared times dx because it's already here, it's already existing, right? So that means that we can do 1/9 du equals x squared dx, right? So since we have this, we can plug this back into the equation. So that means we can have 1/9, and then our u is 3x to the third plus 5, so u to the power 1/2 du. And then to integrate that, we get 1/2 plus 1 is 3/2. Reciprocal is 2/3, so 2/3, 1/9, and then u to the 2/3, 3/2, and plus c, right? So we got 2/27 times 3x to the third plus 5 to the power of 3/2 plus c. So that would be our answer. Number two, we have a similar function. We still have a composite function. So we're going to set our inside function 4x plus 7 as our u value. Du is going to equal to 4 dx, right? And then we'll set this as integral. Oh yeah, and then we can try to plug in for dx. So we can do dx equals 1/4 times du, right? So 1/4 times u to the 5th power, and then du, and then 1/4 times 1/6, and then u to the 6th power plus c, which means 1/24 times 4x plus 7 to the power of 6 plus c. So this will be our answer for number 2. Okay, number 3. Number 3 is a little bit more complicated, I would say, but this is manageable. So first, we're just going to find which one is the composite function, and obviously that would be ln x squared minus 6, and then that times 2. That's basically ln x squared minus 6 inside the function of x squared, right? X squared y equals ln x. Yeah, okay? So our u value is going to be u equals ln x squared minus 6, right? And then du is going to be 1/x squared minus 6 times integral or derivative of x squared minus 6 would be 2x, right? So chain rule. That means we get 2x over x squared minus 6 and then just dx, right? Forgot the dx here. Okay, so for that, we have something similar right here, right? X times dx all over x squared minus 6, right? But then we just have a coefficient right here, so we'll divide each side by 2. So 1/2 du equals x over x squared minus 6 dx. And then we'll use that to plug into the equation. So this is equal to 1/2 times u squared, right? U squared, and then just du. Right, and then we'll do integration. So 1/3 times d to the third power plus c, which is 1/6 times u, which is ln x squared minus 6 all over, and then not all over, to the power of 3 plus c. Remember to always include the c at the end, since that's the constant that's unknown. Okay, and then number 4. This one I think we've done before, but I think we've done this for trigonometric integration, but just as a review, this is also using U-substitution. So, okay, and then I think for these type of problem, the key is to figure out which one has the odd power, and in this case, that would be sine to the third x, right? So we're gonna leave sine to the third x, right? Okay, so sine second power times cosine power times sine x dx, right? Okay, and then we're going to consider, so we're going to try to see which one is going to produce the sine x dx when taking the derivative of. So when we take the derivative of u equals cosine x, right, that makes du equals negative sine x dx, right? So this is the shape that we want, and then negative du equals sine x dx, right? Okay, and then putting everything back in terms of u, we're going to say u squared, right? U squared times, and then sine x is equal to trig identity, right? So sine second x equals 1 minus cosine squared x, right? So we're just going to plug that in, so that means 1 minus u squared, right? Okay, 1 minus u squared, and then this part is just du, except that we have to put a negative right here. Alright, and then we're going to distribute this so that we can do it more easily. U to the second power minus u to the fourth power, right? And then du, this whole thing, which is basically going to be negative, and then 1/3 u to the third power minus 1/5 u to the fifth power plus c, or negative, and then 1/3 u, which is cosine x, so minus 1/5 cosine 5th plus c. So this will be our answer. Okay, and now moving on to number 5, 2x to the third power minus 9x to the second power all over cube root of x to the fourth power minus 6x to the third power dx. Wow, so that was so complicated, right? Let's see. And then here, we can see that this denominator is also a composite function, right? It's a composite function. So it's this thing inside y equals x to the 1/3 power. Oh yeah, x to the 1/3 power, right? So we're going to say u equals x to the fourth minus 6x to the third, right? And then du equals 4x to the third minus 18x to the second power dx. Yeah, and something looks a little bit familiar to me, right? This is essentially 2 times 2x to the third minus 9x to the second dx. And then we see that in the numerator. What a coincidence. And then we're going to divide each side by 2. So 1/2 du equals 2x to the third minus 9x to the second dx, right? Okay, and then let's plug this back in. So we got u to the negative 1/3 power, right? U to the negative 1/3. And then this whole thing is du, okay? 1/2 du actually. So that's that. And then we're going to integrate now. So 3 plus 3/3. So we're going to say 1/2 times 3/2. And then u to the 2/3, pretty confusing, plus c. And then that means 3/4 times u to the 3. How about we just plug this in? U equals x squared, x to the fourth, minus 6x to the third power. So yeah, this will be our answer. And then off to number 6, we got integral of sine x times e to the cosine x dx. So again, this one is the composite, right? And then so this is y equals e to the x, and then just cosine x. Yeah, so cosine x is the inside function, so u equals cosine x, du equals negative sine x dx, and we have a similar shape here, so negative is going to be divided in both sides, so negative du equals sine x dx. Okay, so we'll plug this back in. So e to the cosine x integral of e to the u, and then this thing will be negative du, right? That means that we get just negative e to the u, right? Plus c, except that we know negative e to the cosine x plus c.